Please welcome Markus Winand.
And thank you. So what I would like to show you today is that evolution, which has happened in SQL and barely anybody noticed. But before we can start about this evolution, the modern SQL part, we would also need to get some common understanding of how SQL originally started. So I'm going back to the original research paper about SQL that was written in 1974. But of course, we don't have the time to have all of this history covered today. So I will skip over to the year 92, when the maybe most famous SQL standard was published, SQL 92. So let's try to figure out what was the idea at that time behind SQL. And only then you will be able to understand how dramatically SQL has changed since then. So on the one hand, we have had the relational data model. I guess everybody has heard of that, but there are also some confusions about that. So let me clarify them. Originally, there was the idea that there are atomic types. And here you have one of these atoms of which everything was built upon. And what you are building with these atoms were basically tables. So we have columns, we have rows, and in each of these cells, we can put one of these atomic values. You see also there is a gap in one place. At that time, SQL already covered the null value, which is not coming from the scientific background of the relational idea, but was already an extension of SQL to the relational idea. Another fundamental idea at that time was that the schema where you persistently store your data should be independent of what you plan to use the data for, what you are doing with that data later on, also where the data is coming from. So a consequence of that is, of course, and you know that quite often data is spread across many different tables. So a consequence of that is that into the language of SQL, there was also a transformation capability built in. Originally, as of SQL 92, only with the relational operators, which were coming from the scientists. So the idea was that if you store all of this data in different tables, it's very cumbersome and unhandy and not very convenient to work with that data, because a single business case could need many tables. So the idea was, okay, this will be a very common process that we need to transform from several tables into something more useful for one particular processing purpose. And this is what SQL actually is. This is the transformation capabilities, originally limited to the relational operators, but now much more. And the really important part is here that on the left-hand side, where we have the data model, the same data can be used in many different ways. And this is a very common requirement we have right now. Like we are doing just different things with the same data. Quite often we are using the data in ways which we did not even think of when we were originally storing the data. So the story in this picture and the really fundamental idea and one of the big misunderstandings of SQL is that the left-hand side relational data model does not need to be changed if there are new requirements on the right-hand side, how we would like to fetch the data to implement one specific job we are just working right now. And on the right-hand side, we can have many different queries, essentially, which transform the static model on disk into something more convenient for processing of each of these requirements. So already at that time, SQL was more than just a data access language. It was something like a transformation language. This is one big important difference which I see there. I don't like the term query language. It's not doing well to describe what it actually is. It does querying, but more importantly, it also does transformations. So now let's look how this picture has changed with the next SQL standard, which was issued in 1999. And it starts with great news. The relational data model is dead. And what you see here is the actual title of a paper published around the time SQL 99 was released. And it was actually published by a guy working on the SQL standard as well. And you see it's kind of controversial. So let's see, what is it about? And to explain that, I would like to give you 2 quotes to get started with. The first one is, to say that these SQL 99 extensions are mere extended interpretations, I really love that term, extended interpretations, of the relational data model is like saying that an intercontinental ballistic missile is merely an extended interpretation of a spear. You see, they are using the word extended interpretation to somehow tell us, yeah, well, it's still there. The root is still there. It's still kind of relational, yet is so much different that just saying it's an evolution of the relational idea is also not the right thing to say. So I will give you the examples right after. But the second quote, I would like to give you first. With SQL 99, you can get the best of both worlds, and of course, you can get the worst of both worlds. It's up to the database practitioners. That's us. It's up to us to do the right thing. And the important message here is there are several ways to use SQL. There is not the only one right way to use it, and everybody must use it that way. There are several ways to do it, and it's completely fine that everybody does the choice according to the requirements. So what is that dramatic change? On the model side, there was an interesting discussion going on in the 90s or even earlier. And I like to quote Chris Date here because he wrote so many books, so it's easy to find quotes from him. And he wrote, "I was as confused as anyone else." And that's actually quite alarming. Chris Date, a well-known database professional, says he was confused. So what was he confused about? It was about the atom. What is it? What do we mean by atomic types? That was undefined. It was a word, and everybody was understanding some different things out of it. So what was meant was clear to everybody, like a string, a text field is an atomic value, a date, a number, all of these are atomic values. They agreed on that. But still there was the argument, the word atomic does not really transport that idea, because if you take a date, you can split it into year, month, and day. So it's not atomic. So they were actually searching for a more descriptive definition. And then he wrote on, by the early 90s, I'd seen the light. And what he wrote then was, domains can contain anything. And in that context, domains just means types, or cells, if you want to say it in that way. So what he found is that we don't actually need a new word instead of atomic, what they were searching for. He just found out that we don't need such a limit anyway. We can put anything in each of the cells. And this idea was taken up by the SQL standard in 99. So they introduced rich data types 20 years ago. Of course, if you build a table, we can still use the good old atomic types. They are still the most useful ones. So it's perfectly fine to still use integer, numeric, and dates and all of these things. But now we also have arrays, and they are completely legal. They are legal in terms of SQL. It's an explicit feature array supported by SQL. And giving the newer definition of the relational model, where we don't use that atomic wording anymore, it's also fine for the relational data model. We got other types like nested tables. We can have an entire subtable in each cell. And maybe more importantly, composite types. So where we can combine different atomic values into something greater. For example, monetary types, where we combine the currency symbol together with the value into one unit, we can then work with, and we can then do all the transformation we are doing for SQL with that one logical unit. So this was the change on the model side in 99. But also on the transformation side, there was a similar change, like it was not limited to the relational algebra anymore. They introduced some transformation operators which just don't exist in relational algebra. And one of them, the recursive query, I would like to briefly demo. So what you see here is a hierarchy. And you see, you might know that system where you have in one table, each element has an ID. So each row in this table is one of the boxes in this picture. and each of them has a parent, and the root doesn't have a parent, but all the other ones have one. And then you can do things like picking one out of them. So if you know the ID of this particular node, then it's easy to query it. You just say where ID equals 42, for example, and then you have it. But the more interesting question is, how could you fetch, for example, the entire subtree there in SQL? So let's have a look. The first step is quite simple. We start with the root node, and we just provide via bind parameter to prevent SQL injection. We are providing the value we are searching for. And then we can already use the union all operator to add more rows to the same result set. And there we are basically doing the same search, the same query, but instead of the ID column, we are searching on the parent column. So we are basically searching the errors here. And all we need to do is to provide the same number as the parameter. So then we get those two nodes here. So this is already possible in SQL 92. But that's also pretty much game over when it comes to SQL 92, because although we can add more union alls, that's not the problem. The question is which value would we search on, because we don't know the parent's parent value yet. So what we would actually do to implement it, we would need to get out these two IDs and then automatically trigger a new search for those that point to them. And this is exactly what was implemented in SQL 99. And the syntax, you see it on the screen already. It's not even a lot of syntax. It's just a wrapper, basically, where we can indirectly refer to the output of our very own query. And in this way, we can go level by level by level on the database side and fetch all these nodes in one go over the wire. And we get them in one list, and we can then do whatever we want with them on the client side. And this is one of the examples of a transformation process which is fully SQL compliant, supported by pretty much every modern SQL database, but it's not based on the relational algebra anymore. So this is the fundamental break we have had in 99, 20 years ago. We are not limited to the relational idea anymore. So this was just one example taken out of SQL 99 that was really a huge standard. There were so many new features introduced. I've just picked the most common one. You see, it's in the meanwhile supported by all the common databases, but it's by no means the only one. I just have to rush on to show you something more interesting features from later releases as well. So let's go on to the year 2003. There were also some interesting changes. Like here you see XML. Who's using XML anyway? So at that time, XML was the big thing, 2003. Nowadays, JSON is the big thing. And in the meanwhile, we have also got JSON. But back then in 2003, when they added XML support to SQL, the fundamental change they did at that time was that for the very first time, it was possible to have in one column structural different data. So the other features which I have shown you, like arrays and nested tables and composite types, they were still like each row of that column must have the same type. So you can have an array of an integer, and then each row must be an array of an integer. But now for the very first time, you could have non-uniform data items in each row of one column. So you could have in one row, you could have an XML which has maybe just some elements, and in another one you can have maybe something deeply nested. It's not a uniform data structure anymore. And this was, of course, also quite hard to incorporate into the SQL standard. And factually, the JSON support we have nowadays in SQL is pretty much based on the ideas from there. So we are reusing those ideas. And you can see there later on, so in the year 2016, the SQL standard was extended to also cover JSON. I will show you an example a little bit later. And on the transformation side, what has changed there? Window functions. Window functions are without any doubt the most important feature that has been added to SQL since decades. I'll show you an example, of course. So what I have here is a simple query, and I also have the result it might return. And these are basically bank transactions, for example. So transaction number 1 is a deposit of 10, and then there's another deposit of 20, and then you withdraw, you take out 10 again. And the question I would like to answer in SQL is, what is the balance after each transaction? So if you put in 10 euros or whatever, then the balance is 10. If you add another 20, then it will be 30, and so on, and so on. And the question is, how can we do that with SQL? It was already possible in SQL 92, but there you needed a subquery. And that's always a performance killer and a maintenance nightmare. Now we have something more easy to do that. So the fundamental idea is that we are now allowed to use aggregate functions such as count, min, max, average, and so on, and also sum, as you see there, without doing a grouping at the very same time. But instead of using the group by clause to define which rows should be aggregated, we need some other syntax, and this is the over clause. So instead of having a grouping at the end, we are using the over clause right after the aggregate function to specify over which rows we would like to do the aggregation. So inside this over clause, we are then specifying things like order by. Okay, that comes as a surprise now, because, well, if you build a sum like 10 plus 20, it pretty much doesn't matter if you make 10 plus 20 or 20 plus 10. But that's actually not the point here, because in the over clause, we are specifying the rows we would like to aggregate. And later on, we would like to talk to the database and tell, listen, database, I would like to aggregate all the rows from the beginning of this account up to the current transaction. And to be able to phrase such conditions, we need to agree on an order first. So what we are doing here is just telling the database, when I say things like before and after, this is the order I'm referring to. And once we have established that order, then we can use these terms. Then we can say, okay, we would like to take the rows between unbounded preceding. That's the syntax they choose for that, which means the very first row. And as it is a between, we also need an and another and the current row. And the interesting thing is this current row, this is the current row the database is just looking at. So at the beginning, it's looking at the first row, and it takes all the rows between unbounded preceding, so the very first, and the current row, which happens to be the first row alone. And this row is then passed on to the aggregate function in front of it, to the sum function, so that you get the result 10. But at the second row, the unbounded preceding is still the very begin, but the current row is already the second row. So now we are spanning over 2 rows, and those 2 rows are sent to the sum function, and it will add them up, giving 30, and so on, and so on, and so on. And as I said, that's really one of the most important additions to SQL for decades. In the meanwhile, it's also supported by all major database systems, and even more. So even the more modern or less traditional databases, if you want to say so, have added supporting this feature. So you see BigQuery there, which is a big player in the meanwhile, Spark, NuDB, and so on. They all support window functions by now. So I like to say there was SQL before window functions, and there is SQL after window functions. And this is what makes the entire difference. It's really a game changer. I can just show you that one example due to time constraints, but I really recommend getting into that topic first. And then I'm skipping over a few releases over the standard. There was one in 2006 and another one in 2008. I'll just skip over to the most recent one, the 2016 version. And as I told you already, we got JSON support there. And here I would really like to show you an example rather than the XML example, which looks very different, very similar, basically. It's almost the same. So I remind you, a big part of SQL is transformation between different formats. Most importantly, the idea is that the persistent data model should be designed in such a way that it can remain static, so that we don't need to change it every time we are changing some requirements or we want to do something new with our data. And then we can just transform it on the fly through SQL in all different shapes and ways, so we can more conveniently do whatever is then required to be done with that data. And nowadays, it's quite common to ship JSON documents over the wire, over the web client, for example, and the web server. And here's the example I've chosen here to demo. There is a JSON document, you see it. It's basically an array having 2 elements, and each of that element is an object having 2 attributes. So you see, it's actually quite tabular, kind of, so it could easily be represented as a table. And this is also the example I would like to show you, how to transform that JSON document into something more tabular, like we did it traditionally in SQL. And this is the entire query. That's it. What we have is a new function. It's called JSON_table. It's a function, it's a table function, as the result is a table. Therefore, we put it into the from clause. And then it needs a few parameters. The first one is the JSON document you would like to process. So I've again used the question mark here to prevent SQL injection, but this is pretty much referring to the example I have on the right-hand side. And then in SQL, we are all the time thinking about columns and rows. So all we need to do is to define a mapping. How can we map the items of this JSON document into columns and rows? And we first start by mapping the rows. And the way we are doing this is using a so-called SQL JSON path expression. And that's something new, but it serves a very similar purpose. Like in XML, we have the XPath language. So it's a language designed to pick out one element out of a JSON document, very much like XPath for XML, or maybe also like CSS selectors for HTML, where you can basically select one or more elements from some HTML, or in that example, JSON document. So what that example here means, that's a new sub-language of SQL. It means start at the root, expect an array there, and take all the elements. So this will hit these 2 objects. And as we are hitting 2 objects, we will get 2 rows out of this function. And that's it. We have already defined the rows. Now we need to define the columns. And for that, of course, we have the columns clause. And all we need to do there is to give it names and types. And we are using the same language again, the JSON path language, to say, pick that element and put it into this cell, basically, column. And that's it. That's the entire thing. So you need to learn this SQL JSON path language, which is not really highly sophisticated. And then you have functions like that. And this is one example, JSON table to transform a JSON document into a tabular form. But SQL has all the other functions for the other way around as well. So you can also transform from tabular into JSON documents. All the functions are there defined in the standard. But nevertheless, that example here, which I have on the screen, is kind of ugly because look, I'm sending some JSON document from the client to the database and then selecting back the result in a tabular form back to the client. And this is really not what I mean by transformation. I think the transformations, they should still be related to the persistent model on disk. To make that example a little bit more useful and to show you how all of these things can combine in SQL, I'll just put an insert up front. What it now does, we are sending a JSON document through that bind parameter to the database, then transforming it according to this definition to this tabular form and feeding that tabular form right away into that table. And there is no ping pong between your PHP application and the database anymore. It's just you send it one, and no matter how many rows are in there, how many documents you have in that JSON array, they will just be stored. And you can, in this JSON table, also define things like default values and how to cope with missing values and null values and all of that, and error handling. All of that can be defined. You just declare it there, then you send it over the wire, and everything else is taken care of. The transformation part between the transient schema you have here and the persistent schema you might have on disk is done on the database side. Oh, the question is, can you use that in your database yet? That was added with the latest release, 2016, to the standard. So let's have a look. Yeah, maybe. So if you're using MySQL 8.0, then you can already use that function, that particular function. Also, if you're using the commercial databases. For the other open source databases, in MariaDB, there's a ticket open. It used to be assigned to 10.5, which is this year's release, but now it was pushed over to the next release. So it's maybe next year, who knows. And on the Postgres side, there is a patch already available. It's already in the ready for committer state, in the commit fest, if that means anything to you, which means there is hope we get it in Postgres with release 13 this year. And then I would like to do some time traveling, because time traveling is exciting. Let's go back to the year 2011. Because in 2011, there was also an SQL standard release. So every 5 years, approximately, we get a new SQL standard. And in 2011, we have got time traveling. No kidding. Time traveling is now an official part of SQL. It's a rather complex topic. So there are two things. On the one hand, we have the so-called application version. I don't have the time to explain that in detail. On the other hand, I will just show you the system version, because this is fully automatic and allows you time traveling. And it works already in one of the open source databases. So let's have a look at this example. What it starts with is we need, on a table by table basis, we can decide to either use these time traveling capabilities or not. If we want to use them, we have to do some preparations on the table definition side. So what is required? We need 2 columns of timestamp type, and they need to be specially tagged. So here I say from until. This denotes the time frame when this version of the row was valid. And there we say generated always as row start and row end. And by this way, we are delegating the maintenance of these columns to the database. We don't need to take care of them. They are there. We can also query them, no problem, but we don't need to care about them when we are writing to the database. And then we need to do a few more declarations to make the magic work. And when we then start inserting data there, these 2 columns, we don't mention them, the from and till, but they are still there. They are propagated. We have delegated the maintenance of them to the database. So the database, when I run the insert at 10 o'clock, it will put 10 o'clock in there. If we do an update, really magic happens. Physically, we will end up with having 2 rows stored on the database. The old one is still there with the X, but the till time has been set to the time when you run the update. So 11 o'clock here. And the new data is then valid from here on. And you guess it. If you delete it, nothing is physically removed from the database. It's still there. It's just the till date is set so that when you query it, you know, okay, if that is in the past already, it's not valid anymore. So this is what we have physically in the system. But if we query it, like we usually query tables, and we just say select star from that table, then we won't get anything if we do that after deleting the row. It's gone. It has been deleted. And all of this magic is transparent to the application. One of the key ideas of the system versioning is that you don't need to change your application. You don't need to change your queries, not your insert, update, delete, and all of that. Unless, of course, you would like to see that old data. For that, we have new syntax. So as it is a table by table thingy, we add it to the where clause right after the table name. And there we say for system time as of, and I would like to see the data as it was at that particular point in time. And if I ask for 1030, then you see it's the X version. And this is what we will get back. And this is what's called system versioning. It's fully declared in the SQL standard, and it's supported by at least one open source database you might use already. So that's MariaDB in that case, supported for some years already there. And they are also working on the other versioning, the application versioning, which I briefly mentioned at the beginning. There's a lot of work to be done, but you see, it's moving. And this is, I think, one of the most convenient features, because you just enable it for one table. You can also use an alter, of course, to alter existing tables to do the magic. And then you're done. You don't need to change your application. The only thing, if you do select star, you will get these 2 new columns. This is what you have to expect, but that's it. So these were just some examples picked from some versions of the standard. What you see here in the picture is a photo of the current version of the standard, of the 2016 version. And to be more precise, it's actually just part 2. There are several parts of it, and this part 2 is the biggest one, the most important one. And you see it's a big stack of paper. What I want to give you a kind of a benchmark, how big is SQL? Compared to SQL 92, which is what most people have learned as SQL, the standard is now 5 times as big approximately. Put in a different way, you could also say that like 80% of modern SQL was actually not concerned about the relational limitations anymore. It was invented after breaking out of the relational cage. So there's really a lot has happened. I cannot show you that in 35 minutes. I've just picked some of the examples. You really need to dig into that to get the full picture. Also very important, it's beyond the relational model. The relational idea is still there. And of course, join is still a very important tool in SQL. It's not that you don't need them anymore, but it's not a limiting factor. This entire relational idea is not limiting SQL in any way, neither on the model side nor on the transformation side. And that's really something really important to get, because many people still think, oh, we have to stick into relational understanding, sometimes with the outdated relational understanding that everything needs to be an atom. That has completely changed since then, 20 years ago already, basically. And to summarize it, if you use SQL only to do CRUD operations, like creating, reading, updating, and deleting single rows most of the time, mostly by primary key, then you are actually not using SQL. You remember, SQL is more than a query language. It's also a transformation language. If you're not using these features, like the recursive queries, the window functions, time traveling, all of these things, the transformative power, then you are using just so much of the SQL syntax, just the query part of it, and you let out the most powerful part of it. And I find that quite sad, to be honest. So, and then there is this website, modernsql.com. Of course, it's my website. It's my website where I explain you these features. You can read about it. It's entirely free. Subscribe to the newsletter and all of that. And of course, you can follow it on Twitter. You can also follow me on Twitter, and you can contact me to get training. So I think I'm pretty much in time, and I'm waiting for questions. But I can't.
It blew my mind. That was. Can you hear me now?
No, yeah. Yes. Now I can hear you.
All right. Perfect. Awesome. Wonderful. So I was just saying that the over keyword that you were describing completely blew my mind. And I was watching the chat, and it looks like a lot of people's minds are being blown as well. Somebody even used the word mind blowing. So that's great. Dimitri did. So thanks so much for sharing all this awesome greatness that's coming from the 21st century SQL stuff. We are going to be grabbing some questions out of the Zoom room. And if you would like to join for some Q&A, make sure to look for the Zoom room link, which was just posted in the chat for the live stream. So feel free to pop in here and get some Q&A going. Until we get a question going, I do have a question about system versioning. This is really cool. It looks like you're able to basically just keep the whole entire state of everything that's happened in your database, kind of in a similar way that someone might implement like event sourcing, where you're sort of like kind of keeping track of your entire history over time. Is this a good way to implement something like event sourcing?
Oh, that's questionable. I mean, I see the context, event sourcing, and it's actually quite easy to implement different ways of event sourcing in SQL. So yes, but I'm not sure if that is the right feature for that. So that time traveling is really, on the one hand, the system versioning, which I've shown you, is really there more for auditing purposes. This is what it is most of the time used for. On the other hand, the other thing which I just briefly mentioned, the application versioning, you see there are two different things we have to consider. There is, on the one hand, there is the time when something happened. And on the other hand, there is the time when we learned about something happening, which is typically later. And these two things you see there, the application versioning is there to keep track of when things actually happened in the real world. Like a name change, which might have happened due to a marriage, we might have happened 3 weeks ago, and we are learning about it now. And the application versioning is there to keep track of that. But for that, we need the capability to say, okay, that update, apply that update as though 3 weeks ago. So we need, on the writing side, we need to put in additional information like this update happened as of something. So all of the insert, update, delete syntax changes for that. But here we are just keeping track of when we learned about it. And when we entered it today in our database, then the database can automatically say, okay, now I learned about it, so I can take the system time. And that's the trick, how the system versioning works fully automatic. So this is what these features are intended for. And of course, they can be used for other things as well. But the event sourcing, I would actually implement differently in SQL.
Awesome. Excellent response. Thank you so much. We do have a question ready to go, I believe, if we want to switch over to the Zoom room.
To the Zoom room. Hold on. I need to
yeah. Hey, Markus,
window, maybe.
do you hear me?
Yes, hello. Yes.
Thank you for a great talk. It was really mind-blowing. You gave us a lot of examples how SQL databases adapt to new reality, a lot of amazing features. Could you say is SQL database?
Okay, the audio connection just broke. Can you repeat?
Oh, sorry. You gave us a lot of examples how SQL databases adapt to reality, have new really good features. But could you say there are no SQL database than SQL databases?
Sorry, it just broke again. I'm missing the question. Are you asking about NoSQL?
Yeah, I'm asking about NoSQL. Where is NoSQL database still more suitable?
Where is it still more suitable? That's an excellent question because it's positively phrased. I mean, what's left, you're asking. There is traditionally, there are some things which SQL isn't like so flexible. Like in the relational model, we have seen it's kind of flexible, but there are some other things where it is not so flexible. Like when it comes to ACID and transactions and all of that. SQL is not flexible. SQL doesn't give that up. So when you think about the CAP theorem and scale out and all of that, if the availability is more important than the correct response, then some NoSQL store might be a better option. That's how I would put it. So if one of the things which SQL requires, not optionally but mandatory, and these things are a limiting factor for you, then you should start looking about alternatives. But frankly speaking, nowadays a single database instance can cover so much load that we all wish we would have that problem that we need to scale out to billions of CPUs or whatever. But unfortunately we don't, or fortunately. So quite often a single instance is just fine. So, and then you don't, then all this transaction safety is kind of easy.
Okay, thank you, Markus.
Wonderful.
Welcome.
Thank you so much, Markus, for that excellent talk.
So waiting for Markus. to ask more questions?
So, hello.
Hello again.
Hello.
We have a couple of questions from chat. Let me read it. First is, what about storage procedures, functions, and views? Does it make sense to use them in 2020?
So stored procedures, functions, and views. Two of them are quite different from the third one. So the views are a different thing, actually. The views are really just an SQL feature, an old feature, a good feature. It's there to maintain SQL thingy. On the other hand, the functions and procedures, they open the door to procedural programming. And that's something which we actually don't have in SQL. SQL is a declarative language. We are not programming in that sense that we are putting instructions in a specific order so that when the instructions are executed, that we get the result we would like to have. That's not how we write SQL. SQL is written by declaring the result. We would like to get these columns. We would like to get those rows. So procedures and functions, they are a way to access imperative programming from within SQL. And when we go back now in time again to SQL 92, because that was so important, that was really needed because of the limited capabilities of SQL, because it was, it was so limited to the relational idea, or only joins and nothing else than that. Everything, the join was the answer to pretty much everything at that time. And of course, that's not true. There are other algorithms which could not be expressed in the declarative SQL language. So if you still want to run them efficiently, then you need an imperative language. And this is where the procedures and functions come into the game. But nowadays, fast forward 20 years, 25 years, when we go back to SQL 92, 28 years, holy. Nowadays, SQL, you have seen, it's not so strictly limited anymore. So the number of times we need to use these features have just dropped significantly. There might still be cases, no question. But in my personal experience, they are becoming every time more rare, where there is a good reason to use them, because we can do the similar thing in a more expressive way, in a declarative way, and most of the time more speedy way and more correct way, using just the modern SQL features. So they still have their place, but yeah, they're not as important as like 25 years ago.
Okay, cool. Could you say, is it a good idea to have a business logic inside and functions?
Mm-hmm. Yeah, the word business logic, there is like a holy discussion where what shall be done in the application layer and what shall be done in the database layer. Let's try to use a new word there, maybe data logic. Let's say, okay, the business logic, the truly business logic, okay, let it live in the application layer. But what I've shown you in SQL, the transformative part of it, let's say, okay, this is data logic. Like which rows, which data do you need from the database to do your business logic? If you think of the tree, which I've shown you, then you need something more advanced, like the recursive query, to express that in SQL, and we have that now. And I think expressing the data which you want like to get your job done in the application layer, that is something which I refer to as data logic. And I think data logic is exactly what SQL is good at. And it's okay to use that. Of course, you could also put in business logic in there. I'm not on the one side, neither on the other side. There's a continuum. Everybody has its favorite spot, okay? But what I would really like to tell distinct from the entire discussion whether business logic should be in a database or not, is that I would like to coin the new term data logic and just bring the idea that is something which should definitely be shifted to the database.
Okay, thank you. Another one question from chat. What do you think about sharding problem? is there a good solutions coming for that?
For which problem?
Sharding.
Charging?
Sharding.
Ah, sharding.
Yeah.
Okay. Yeah, as I told you with the other question, so SQL is not very flexible when it comes to the integrity constraints. So I don't know. There are some technologies, but they are, of course, not as powerful as some NoSQL solutions because they enforce the constraints. I don't think that there will be a big change. On the other hand, yeah, well, if you think just about SQL, let's take BigQuery as an example. Sharding. So when we think about BigQuery by Google, I mean, I don't know how it works in detail on the backend, but they don't support primary keys. They don't support foreign keys. So they are giving up some of the things which are actually mandated by the SQL standard. So they actually cannot really claim to be an SQL database, even though they support a big deal of it. So maybe it's getting better, but I'm a little bit, I don't want to do any prognosis here because it's just too uncertain to tell. But on the other hand, really BigQuery and also the Apache project like Think and so on, they do support SQL, just not all of the mandatory SQL.
Okay, thank you, Markus. The next question. If you save complex data in Excel, there is a problem how to extract a part or change a part of this data. Is it an issue?
Yes, absolutely. So the SQL standard does not define a way, if you, for example, store a JSON document in one single cell to update just a part of it. That's just not there. You need to fetch it and replace it. You can do that on the server side, but basically you need to overwrite it. That's by design because that's still kind of atomic. You know, one thing is one thing you can change. That's the smallest unit of change is one cell you can do. There are some extensions by vendors which make that more flexible. So
sorry, Markus, looks like your mic is muted. Yeah.
It's not muted. Can you hear me?
Yeah, I hear you now.
Okay. So what I was saying is that personally, I'm still sticking to the idea that we use for the persistent data model, for the on-disk data model, the data model that should be independent of where the data is coming from and what we plan to do with the data. That data model still should use most of the time the atomic types, if you want to say, because, yeah, for example, the update is not very well solved yet in SQL.
Okay, thank you. Next question. Thank you for this great report, but what about the SQL future? Which ways from your point will be improved and added?
That's a great question because the next standard is already in the works. So maybe next year we will get a new standard. And the things which are being worked on right now is a graph query language. Like if you know Cypher from Neo4j, something like that directly in SQL. This is what's being worked on right now, and it's already quite far, that project. So we expect that to be there next year, maybe, probably next year. So that's one of the really big things which is coming to SQL soon. And then there are some other projects which are not yet so far. We don't have a target date for them. One of them is, for example, streaming data. So also the Apache people are contributing a lot into the SQL standard, and there are discussions going on how to incorporate this into SQL. So this is definitely one of the things which is thought about. Doesn't mean it will come. And we will, of course, also get extensions of existing features. For example, also the next standard, the 2021, we will have more JSON features, for example. So we will get more of what we already have. We will get one big new thing, the graph query language, to graph traverse like Cypher, if you know that, the Cypher query language, and possibly more. But this is what I know as of today.
Okay, Thank you. Another question from Ivan. I wonder about foreign case using complex types like arrays, XML, JSON, and so on. I mean, is foreign case supported by this complex type?
Yeah, also a good question. And it goes hand in hand with the answer I've given you before. Like for the persistent data model, I still prefer the atomic data types. I actually don't know. I've never done a unique constraint on let's say, a JSON. Technically, a JSON document in the SQL database is just a varchar, basically. It's a string. So everything you can do with a string, you can also do with a JSON document. You could do foreign keys. You can, of course, also pick out some items of a JSON document using this JSON parse language and use that in some way in some constraints and so on. But still, the actual solution I would take is if you want to use these features like unit constraints and foreign keys and all of that, it's probably better to do it in the traditional way.
Okay, thank you. We have quite dangerous question in chat. What is your favorite SQL database?
Pardon? What? Wow, my favorite.
Yeah, favorite.
Okay. There is the politically correct answer that I don't have a favorite. So it's not only just politically correct. So each of these products have their strong points and their weak points. So for some of you, MySQL might be the perfect choice. For others, something different might be better. So if you know what you plan to do, then you can pick the perfect one for that purpose. Nevertheless, if I was on a green field and just would like for a new project, pick any database at random as a safe point to start with, then I would take Postgres.
Okay, thank you. What do you think about new features in SQL? What do it needs?
Yeah, I think we have already had the new features question. Yeah. What it still needs, there are some smaller points, like the system versioning I've shown to you. It's nice, it's great, but it's not perfect. We need more refinements on these features. But what I also think is what we need is the people actually demanding those features from their vendors and start using them. I think that's the most important stuff. Once we get into using them, then we will understand what's missing, and then we can evolve again. So I would really like you basically to start about reading them and then just ask people how to solve certain problems. And if problems arise out of them and limitations, then they can be taken care of.
Okay, cool. Our participants ask about an example of data logic and business logic. Where is the difference?
Mm-hmm. So the example I can give you there is, maybe I'm going back to this hierarchy model. Like if you query that hierarchy, this happens in many different cases. For example, in a factory, you might need to know which items you need to produce one piece. And then the data logic is basically to identify the subtree. And then the business logic might be something like triggering some processes based on what these things are, or doing some decisions basically on what's there, what items, how heavy is it, how can it be transported, and these things sorting out. That might be business logic.
Hello.
But of course, I think when it comes to calculations, for example, then it's more commonly like business logic. And when it comes to the way I define the data logic thing is to define the data you need to implement the business logic. This is how I define the data logic. So I hope this somehow helps.
Well, we have a very big question. So I'm trying to read. I'm developing an application for internal use. There are just few users and a very large database, more than 100 inside the DB, small one running because process millions of rows. From scale 5.7 to 8.0, overall performance reduced. It turns out that modern databases are optimized for huge amount of small parallel queries, but badly dealt with single head queries. Could you give me an advice? Are there better DB engines for processing large amounts of data?
So, coming to this example, MySQL 5.7 to 8, that was a really big leap. Many improvements were done also on the back end here. So MySQL, they have kicked out so much chunk out of MySQL and improved, make it more reliable, really much more reliable. So that might be the reason why it has become a little bit slower on some parts. But generally said, I wouldn't say generally that modern databases are not designed for small queries. I would probably agree that MySQL is designed for that because that's common in the web scenario. But thinking abstractly, SQL as a declarative language can be executed by many threads in theory. It's just that MySQL cannot do that yet. So if you compare that, for example, to the commercial databases like Oracle, DB2, SQL Server, they can do parallel query execution for decades, really decades. So you just toss over a single query and your entire 64 cores or how many you have, they work on getting that one single query done for you. And it really works off. It's really much, much faster that way. MySQL on the other side, MySQL doesn't have that yet. If you want to stick to the free open source part of the database vendor spectrum, then Postgres might be an option here because Postgres has parallel execution for some versions now. So for like 3 years, maybe. It's still evolving. Not everything can be done in parallel in Postgres, but much more than in MySQL, for example. So if this is your use case, then I would indeed say MySQL is probably not the right choice because as you said, MySQL is good at doing many small things. That's what they are benchmarking mostly. And they are adding the more complex features like window functions. And so just as a check mark item, okay, we can do that as well, but they are not putting so much optimization efforts into these things. So this is just my personal opinion. For that kind of workload on the open source spectrum, Postgres might be a better choice.
Okay, thank you, Markus. Looks like we out of questions. Could you please choose the best question and we give the author book?
The best question. Let me just go through it. Okay, the first one is Russian. I think what I really liked is the question about foreign keys and XMLs and arrays and all of that, because that proves some, it's a new question. I don't get that regularly, so thank you. So this is my pick.
Okay, cool. Thank you, Markus, again for your great talk and for a good discussion.
Okay, there's the one question about the PHP library. Maybe I should briefly just cover that because I think we missed it.
Oh.
And
yeah, I missed it.
It's hard to admit for me at a PHP conference, but I'm not using PHP a lot. So I cannot tell you my favorite library because I'm not using any of them regularly. So I'm sorry, I don't have any good answer here.
Okay, that's no problem. Thank you and bye-bye. Ivan, could you please contact organizations and we give you your present. Thank you all.
Thank you.
Bye.
Welcome. Bye-bye from Vienna.